Okay. So, last lesson, because we're going to skip the binomial probability formula. Bring it in. Guys, what's up? How you doing? Last lesson of this chapter, because we decided not to do the binomial probability formula, which kind of goes with expected value. It's why I do expected value at the end. Expected value is actually a pretty easy subject in probability. So take that as you will. Now, here's the thing about expected value. Expected value should be thought of as an average. Okay? For example, if you play a game and there's a certain percent to win, there's a certain percent to lose, and you make like $10 if you win and you lose like $20 if you lose, right? If you play that game an infinite number of times, the expected value is how much you would take home or have to pay, right? It's basically what this all will lead to if you keep going. So, how would you use the expected value in a business or something? If you get lucky and you see the exact expected value is a lot lower than that, you stop, right? Like gambling, you know what I mean? You don't let it ride, ever, because that's how you lose your money that you just got. If you get lucky, you stop, put it away, you know what I mean? You don't, you just stop anyways. There's a lot of fun in that. It's called not being in debt, keeping your house, your wife not divorcing you. Well, your wife still might divorce you. I guess that depends more on your personality. Because, I'm not saying she's a gold digger. Okay, here's a formula for the expected value. The expected value is going to be the probability of an event occurring next time you turn around, I'm chucking this at you. My aim is bad, so it's going to hit Peyton right in the face. The expected value is the probability that an event occurs times the amount that you get if that event occurs, plus the probability that a different event occurs times the amount you get if that event occurs. It's basically taking the probability of something happening and multiplying it by the winnings you would get, and then adding all of those together at the ends. Okay? And that's going to give you what you are expected to take away if you play that game a bunch of times. Formula looks scary. It's actually not so scary. We're going to break it down in a really nice and easy way. Okay. So we're going to start with Spirit Airlines. You guys ever flew Spirit Airlines? I have. It's so cheap that I don't care how bad it is. I'm like, who cares? It's just like 2 hours of flying. If I have to be cramped and sniff something I don't want to sniff. Huh? It was like $100. It was so cheap. I mean, it's a risk I'm willing to take. Save $100 or die. Sure am. Risk it for worse. Come on, we all know, we've been there. We've all been like, hey, but you won't do this. Like, yeah, I will. It's super dangerous. And you do it just for the pride, right? We've all been there. Maybe not. Maybe it's just me. Anyway, so Spirit Airlines is considering adding a route from Pittsburgh to Nashville before making a decision. The company needs to consider many factors, including potential profit or loss. After considerable research, Spirit estimates that if it adds the route, there is a 60% chance of making an annual $800,000 profit, a 10% chance of breaking even, and a 30% chance of losing $1 million. How much can Spirit expect to make annually on this new route? So, first comes first. as a reminder, you're looking for, if you do this year after year, can you expect to gain money or to lose money? Okay. So this isn't just a 1 year thing. This is a multiple year thing. That's what this means. It's the average of every single year's probabilities. Okay. What we need to do is break this down. There's 3 different options. We have probability 1, probability 2, probability 3. Now, the first thing that can happen is they gain $800,000 in profit. And what are the percent chances of that happening? 60% chance. We're going to write that as 0.6. Then we can see there's a 30% chance that they lose $1 million. So how do you think I'm going to write losing $1 million? Negative. Good. It's like they're gaining negative 1 million. But then there was a third option, right? There was a 10% chance that what happens? They break even. And what's break even mean? They make no money, but they don't lose money, right? So it's just big fat zero. And like I was talking to Jack about yesterday, this zero is important, right? And you can think of it as kind of like this. If you don't do a homework assignment, what do you get? 0. Does that grade bring your grade down? Yep, it should. So it does matter. It should. Should absolutely. If you don't do your homework. In fact, we should change. I think you're right. Actually, if you don't do your homework, it shouldn't count against your grade. But I get to whack you 3 times for 0.
I would take that. I would take that. 100%.
I would take it all day. As hard as you can.
On my back.
Can we make that a thing in this class?
Please.
We'll keep this.
Yeah, I'll ask Mr. Marshall, see if we can do that.
Shut the door, lock the door. We don't have to tell anybody. I will take a 0. You're not going to say
I won't do nothing.
Our backs are good.
I think you would change your mind after like 1 whack. Okay. I mean, you think so?
Yeah, I think
That's gonna hurt real bad.
No, I swear. You're going straight down like on our
I would do it like a little baseball.
On your, like, maybe
Yeah,
not.
like,
Your
are
head.
you going side?
I could.
Yeah, go side.
Ooh, yeah, that's definitely better.
But hey,
3 of
how many are
those.
we getting before break?
Huh?
How many are we getting before break?
3 of those.
3 for 0.
But
What
would you want to do homework?
I mean, would you do the homework if that was the consequence?
No.
I wonder. I bet you would.
I would take.
I think like violence is a big motivator, right?
I would take that. I would take the 3. I'd take it.
I mean, think about when you're a kid, right? If you like say no to your mom and dad, they're going to spank you, right? Then you're not saying no. Watch your mouth. Yeah. All right. Anyway, funny time. From here, what we need to do is take each one of these categories and multiply them together, and then add them at the end. So I'm going to do this in a separate step this time, but usually I put all that in the same step. So what we're going to say is P1 times A1 is equal to 0.6 times 800,000. Which is 480,000. P2 times A2 is 0.1 times 0, which is 0. And P3 times A3 is 0.3 times negative 1 million, which is the amount of money I'll have if I actually do hit you guys with a stick, because I will get sued. Someone would steal. It would snitch. Which is negative 300,000. If I add all of these together, I get my expected value. That's going to give me 480,000 plus 0 plus negative 300,000, which is $180,000. That's your expected value. Now, I want to reiterate what this means because I think the meaning behind the math is more important than the math itself. Okay. Does this mean that Spirit Airlines is going to make $180,000 every single year they have this? No. That's not even an option of what can happen, right? The options of what can happen at this point is they get $800,000, they don't make any money, or they lose $1 million. But this is an average. It's exactly right. Because they have a higher chance. Let's think of it this way, even. 10 years goes by. Well, 6 of those 10 years, they'll probably make $800,000. One of those years, they'll probably make $0. And then for 3 of those years, they'll probably lose negative $1 million. So you're adding that 600,000, 600,000, 600,000, or I'm sorry, 800,000. Then you're adding negative $1 million 3 times, and then you're dividing by 10 to get that average. Okay? Altogether, that's what you would get. So you're not saying they're going to make $180,000 per year. You're saying if you took all of their profits and losses and found the average of those, it would be $180,000 per year. Okay? On average. Gotta make that sure that's clear. And even then, don't forget that probabilities are definitely volatile, right? Just because the probability is a 60% chance of making $800,000 doesn't mean that 6 out of 10 years you're going to make $800,000. It means that's likely, but you can make $0 all 10 years. It's not likely to happen, but that's totally what could happen, right? You could lose $1 million all 10 years. But the fact that the expected value is positive means that it's probably a good idea to go ahead and do this because you will make money in the long run, even if in the short run you don't make a ton of money. Okay? That is something about expected value. It tells you if something's worth it or not. All right? Let's do another one. I actually really like this question a lot. Maria is taking a multiple choice exam, which there are 5 possible answers for each question. The instructions indicate that she'll be awarded 2 points for each correct response. She'll lose half a point for each incorrect response, and that no points will be added for or subtracted for answers left blank. This is a good question because this is how the SAT used to be. You lose points for incorrect answers, but you don't lose points for blanks. What does that discourage? Guessing. So what we're going to do here is we're going to pretend like this is like, I don't know, 13 years ago when I was your age. And we're studying for the SATs, and we're trying to determine, is it going to be worth it to guess to get the right answer or not? Okay? Because there's instances where guessing is worth it and guessing is not worth it. And you might understand that these instances are when the expected value of your guesses is positive. Okay? So first, doing A, we're just going to find the expected value right now. If Maria does not know the correct answer to a question, is it to her advantage or disadvantage to guess at an answer? So there's 2 possibilities, right? She gets it right or wrong when she guesses. And we know if she gets it right, wrong. If she gets it right, she gets 2 points. If she gets it wrong, she loses half a point. Those are the 2 possibilities. We're going to pretend that she's going to guess here. We're not going to say blank's a possibility, okay? There's 5 questions. What are the chances that she picks one of them at random, she gets the right answer? 1 out of 5. That's a 20% chance. And if there's a 20% chance she gets it right, what are the percent chances she gets it wrong? 4 out of 5, which is 80%. Because remember, 2 complementary events, they add up to 100%. And 2 complementary events can be broken down to, is it going to happen or is it not going to happen? It's going to be one of those 2. From there, we can find the expected value is going to be P1 times A1, 0.2 times 2, plus 0.8 times negative 0.5, which we can just put in a calculator. And again, this is P1A1 plus P2 times A2. And if you put it in the calculator, you really don't even need to be careful about your parentheses or anything, because it's going to do all the multiplication first and then the addition second. Okay. So you can literally, and this is why I really, really like these questions. You don't have to think about the math at all. You don't need to think about the PIMDAS. You just plug that in to a calculator. So you get 0.2 times 2 plus 0.8 times negative 0.5, 0. Which means if she guesses on this whole test, is there an advantage? No. So would it be better to guess or not guess in this case? In this case, we would call this pretty fair, right? That's up to you if you want to guess or not. However, I would say the potential downside of guessing in this case probably outweighs the good side. But you are likely, if you do this, to gain as many points as you lose, right? So if you guess 5 times, it's likely that one of your guesses is right, 4 of them is wrong, 2 points for the right answer, minus 2 points for the 4 wrong answers, right? So it averages out to 0. But that's like 1 out of 5, right? And we all know that sometimes in multiple choice tests, you get something like, what's 2 plus 2? 4. 16 over 4. 400%. All the ones that are kind of hard to find the right answers. Then you have E, elephant. 2 plus 2 equals elephant. Right? Or we're like, oh, that's stupid. That's ridiculous. That's not the right answer. Essentially saying, like, if you have any idea what you're doing, you generally can eliminate at least one answer, right? So let's say we do eliminate one answer from a multiple choice test. Let's see if our expected value goes up and now it's worth it to guess. So the only thing that's going to change here is the probabilities of something occurring. So this is still actually going to be 2. So if I eliminate one choice, I'm like, I know that's wrong. 2 plus 2 definitely is not elephant. Right, Karina? 2 plus 2 is an elephant? No, she's right. She learned something today. Then what are the chances of getting the answer right at this point? 1 out of 4, because we eliminated one of the answer choices, right? Which is a 25% chance. Which means the chances of getting it wrong is a 3 out of 4 chance, or 75%. So our equation does just change slightly, but let's see the effect. Now if I actually plug this into my calculator, 0.25 times 2 plus 0.75 times negative 0.5. I get 0.125. Now this means that if I do guess on all the questions on the test, it's likely that I get a positive score. At this point, do you think it's worth it to guess? I'd say so. At this point, you're more likely to get positive answers, even if you don't guess all your answers right. You're still likely to get more points out of guessing than not at this point, right? And what happens, do you think, if you eliminate a second answer? It goes up again, right? How about a third answer? It goes up again, right? When you're taking a multiple choice test, keep this in mind too. Your best bet is to eliminate as many answers as possible if you don't know what you're doing, and then go with the one that sounds the best. Okay? Keep that in mind because the final is multiple choice. Now, my multiple choice tests are a little bit more brutal than others because I don't have an obvious wrong answer. But they're not any different than the normal test, just I give you answer choices this time. What's up?
Are you one of the teachers that will let us take it early for you to be on the test day?
What do you think?
I don't understand.
You think I'm a stickler for the rules there, Charity? I sound like I like the rules. I'm a rule follower. I am. No, we can't take it early. Unless you have a signed permission slip. Stick is fine. You have to have a form from the office if you want to take it early that you're not going to be here on that test day. But no, I gotta give it to you on the final day. It's like a big rule. I know some teachers don't, but don't follow it. It's not going to be me, man. I'm trying to get a promotion. Okay. I think that's pretty much it. I think the rest of these. Oh, fair price. The fair price that something happens is the expected value plus the cost of play. Write down that formula, and that should help you answer some of the questions on the homework. But other than that, I think that's pretty much all we want to cover today from this. Who said boo? Karina? Oh, on my nerves today. We'll stop being on my nerves. Okay. When's the test? Tuesday, by your own choices, right? You guys got to choose that. Tomorrow we'll start studying for the test. I do have a study guide that I'll give you guys. Take test Tuesday. If you guys aren't going to be here Tuesday, but you are going to be here Monday, it'd be better probably take it Monday. But if you don't take it Monday, that just means you're going to take it after Thanksgiving break. Okay. So if you're not going to be here Tuesday and you don't want to take it after Thanksgiving break,
How many whacks to get 100?
Find out along the way.
hold on, let me stop recording first.
Oh, you got the other part. What you were talking about.
Sure did.